Welcome to qnawire.
So for this question, we're told that Sarah is standing 12 meters from the base of a tower. So let me just sketch that out real quick. So here is Sarah, and she's 12 meters away from the base of the tower. And it says the angle of elevation at the top of the tower is 38 degrees. So let me go ahead and find the height of this. So we can see there with the height being the opposite side and the 12 being the adjacent side that I want to write a tangent equation. So I'm going to write tangent of my angle measure 38 degrees is equal to the opposite h over the adjacent 12. So we can simply solve this equation by multiplying both sides by 12. So we're going to get that h is equal to, and I'm going to type this into the calculator, and I'm actually going to store it into h. So I'll write what the approximate for the h is right now, which is 9.38. But when I calculate with the height, I will always use this h that's stored in the calculator. All right. Now it says that Seth, who is standing 8 meters from Sarah, but he's not in line with Sarah, and that the angle of elevation to the top of the tower is 63 degrees for him. So let me draw. Let me go back to. Okay, so here's Seth. His angle of elevation is 63 degrees. And the h is going to be the same. I'm just going to write h there, and let me call this just d for distance. So same thing here, same idea. We're going to have opposite and adjacent here. So let's write a tangent equation for that. So the tangent of 63 degrees is equal to, again, opposite h over adjacent d. And again, remember, h we have solved for already, so it's not really a variable in our equation. So we have the shortcut here if our variable is in the denominator that we can just switch it out with the other side. So d is equal to h over tangent 63 degrees. And again, I'm going to type this into my calculator and store it in d. And again, I'll just write the approximate right now. So that's about 4.78. Okay, that means Seth is 4.78 meters from the tower. And it says that Seth is also standing 8 meters from Sarah. So let me draw so this is obviously, these are two side views. Let me draw a top view over here, a top view. Okay, so here's going to be my tower, and then we'll let this be Sarah, and then we'll let this be Seth. Okay, and we're told that Seth is 8 meters from Sarah. We know that Sarah is 12 meters from the pole, so let me put 12 down here. And then we just found this distance here, d. So again, I'm going to put d here because I'm going to operate with d. We just found our distance. All right. And so it says if you're standing at the tower, then what is the angle from Sarah to Seth? So we're looking for this angle right here. Okay. So that's not the greatest theta there. Let me try again. So put an angle theta there. And again, I can find an angle if I know the three sides by using the law of cosines. So let me go ahead and do law of cosines there. And then again, I'm looking for the angle, so the side opposite the angle has to be isolated. All right, so I'm going to need to isolate the 8. So I'm going to have 8 squared is equal to 12 squared plus d squared, and then minus 2 times 12 times d cosine of theta. All right, and so let's look at this. So I'm going to have this 8 squared. So all of this is connected with multiplication. So I'm going to save that for a second. And I'm going to go ahead and subtract 12 squared from both sides and d squared from both sides. So 8 squared minus 12 squared minus d squared. Okay, and then this negative 2 12d is connected to the cosine with multiplication. So I'm going to divide both sides by that. Negative 2 times 12 times d. and that's going to equal the cosine of theta. Well, the way I solve for theta, if I have cosine of theta, is to apply the cosine inverse to both sides, right? So I have to do the cosine inverse of that mess. And when I do that, I get the theta equals 26.26, and it says round to the nearest whole degree, which would be 26 degrees. So that's the angle that you would see if you're standing at the tower, base of the tower.